Today's lesson is on rational numbers, specifically simplifying fractions, with a little bit of integer review. When it comes to the addition rules for integers, you got to remember that a positive plus a positive is equal to a positive, and you add those numbers. A negative plus a negative is equal to a negative, and you add those numbers. When the signs are different, whether it's positive plus a negative or a negative plus a positive, doesn't matter which comes first, the answer or the sign of the answer will be the sign of the number with the largest absolute value, and then you subtract those two numbers. When it comes to the subtraction rules, sometimes it's best to turn those subtraction problems into an addition problem. Whether you keep, change, you add the opposite, or slash and dash, you got to remember, you want to change those subtraction problems to an addition problem. And then once you've done that, then you just follow the rules for addition. For the multiplication rules for integers, you got to remember a positive times a positive is positive, you multiply the numbers. A negative plus a negative is positive, then you multiply those numbers. When the signs are different of the two numbers and you multiply them, the answer is going to always come out negative, and you still multiply those numbers. Same thing goes with division. When you have a positive divided by a positive, it's equal to a positive, you divide those numbers. A negative divided by a negative equals to a positive, and you divide those numbers. When you have different signs and you're dividing those numbers, you have a negative number, and then you divide those numbers. One more rule we have to add in, or actually even two more if you want to put in the zero, that when you divide by zero, the answer will always come out undefined. When it's zero divided by any number, that answer will always be zero. Rational numbers. A rational number is any number that can be written in the form of a fraction, a over b, where a and b are integers and b does not equal 0, because then you'll have an undefined number. So anything that can be written as a fraction is a rational number. So the example that was given first is 2/3 is a fraction, so therefore it's a rational number. 0.25 or 25 hundredths is a rational number because 0.25 or 25 hundredths can be written as 1 over 4, which is a fraction. Factors, prime numbers, and factor trees. Factors are numbers that form products. An example of factors would be 3 times 4 equals 12. 3 and 4 will be factors of 12 because they form the product 12. Name other factors of 12, like 1 and 12. 1 times 12 equals 12. Alright, so I challenge you to name another pair of factors of 12. Prime numbers. Prime numbers are numbers that have exactly two factors, 1 in itself. 3 is a prime number because its only factors are 1 and 3. 1 times 3 equals 3. 0 is not a prime number. 1 is not a prime number. 2 is prime. Can you tell me why it's unique? Then composite numbers. Not written down there, but composite numbers are numbers that have more than two factors. And that's important because when it comes to factor trees is just a way of prime factorizing a composite number. 36 can be written, if you look at the factor tree there, it breaks up to 9 times 4, and then 9 can be broken down to 3 times 3, and 4 can be broken down into 2 times 2. So another way of writing 36 in prime factors would be 2 times 2 times 3 times 3, or 2 to the second power times 3 to the second power. And that is prime factorizing with factor trees. Simplifying fractions. When simplifying fractions, what you're doing is eliminating all factors of the numerator and denominator that make 1. By doing this, you're actually simplifying or putting the fraction into its simplest form. So when you look at the example given, 12 over 28 can be simplified into 3/7. Why? Because if you break down 12 into its prime factorization, you get 2 times 2 times 3. For 28 is 2 times 2 times 7. And if you break that up and try to eliminate all the ones, you'll notice that there's a 2 over 2, that's 1. There's another 2 over 2, it's another 1. And then what's left is 3 over 7. So what you end up with is 1 times 1 times 3 over 7. And 3 over 7 times 1, as many times as you want it, is still going to equal 3 over 7. So the simplest form, or simplifying 12 over 28, is equal to 3 over 7, just by canceling out all the ones.